What's up, ladies and gentlemen? So we're back working on the Fanic Arcmate, and we need to give her some beans. So after long and arduous search on the Craigslist, no luck on a three-phase converter. Got 220 single phase, but no three-phase. So instead of buying a very expensive brand new three-phase converter, I decided to build one. Something I've never tackled before, but there's a lot of good information online, so if I do have problems, I should be all good. So I went out to the local, I don't want to say scrap yard, but it's got a lot of junk. It also has a lot of good stuff, and picked up a good deal of components. I do want to mention that I'm essentially following the Fitch Williams design. I'll post a link in the description for those of you who want to follow it. Pretty straightforward. We'll see how it goes. But as you can see, we got some contactors, transformer, bus bar, some good oil-filled capacitors. This big guy, 10 horsepower, 220, three-phase motor, which I'll be using as the generator. Got a nice box to put it all in. One thing I don't have that I will need to order are some starting capacitors and resistors. They were kind of oddball things. He didn't have any there, but those are a dime a dozen. I also picked up some extra wire. So let's get to it. I tried to put it all together in the box to start with, not knowing anything about this system. So I decided to pull it out and mount it on a piece of plywood just so I can get the feel of the layout, and it's going to be a little bit easier to test and troubleshoot if something goes wrong. Well, let's get the motor hooked up, plug it in, and start the countdown. Begin pre-ignition check. Safety systems. Check. Power. Check. Ignition. On. Begin the countdown. 5, 4, 3, 2, 1. Okay, it turned. It turned. I got it working. So at first I thought it was a wiring error, and I went through the circuitry and everything, and I just could not figure it out. And at one point I would start it up, turns one way, and it wants to turn back the other way. So I knew something was obviously not right. Added a few more capacitors, kind of dug into my run capacitor supply, and it starts turning faster. So I knew I was on the right track. I don't have any more large capacitors, so I tried pony starting it, and that worked. So I'll show you how it works, because I am excited right now. I got this thing working. I didn't think it was going to work. Let's give you all a demo. So I'm just going to wrap this strap around here. Turn the power on. So I finally got the motor to start under its own power, but it takes a little long. I'm using the 3-star capacitors that I have, plus a boatload of other ones. What were going to be my balancing capacitors. That's obviously not going to all fit in this case, so I have some 400 microfarad capacitors on the way. Those 3, hopefully, should give me enough juice to get this thing started within 1 or 2 seconds. If not, I can add the other star capacitors that I have. In the meantime, though, while I'm waiting for those to get shipped through the mail, I can start putting all these components inside the box. That's going to be the next task. Once those come in, I hook them up, and I start the task of balancing the 3 legs so that we have nice clean power for the FANUC. Alright, now to take all this stuff and put it in here. Hopefully there's enough space. Alright, finally got him in. What a pain in my parcel. But look at here. Genius me didn't figure out that these come off. So that made it easier. And if I'm lucky and not stupid, we're in trouble then. Nope. Maybe. There we go. She clicks right back in. So everything is affixed to the box nicely-ish. That's a word. Wires going every which way direction. I'm totally lost track of what's connected correctly and what's not. That's just going to require me going back through the diagram and making sure it's all neat and clean. The last thing to put in there, less the capacitors, is the bus bar. Hopefully, I did this right with the bending of a few wires. Oh boy, it's going to be a pain to get some of these wires back behind here and routed to there. But that's right, I can pop these off, so that'll make it a little bit easier. Yeah, we're going to have to work with what we got. I'll spare you the details of this. While I recorded about 6 or so hours of cutting, stripping, and crimping all these wires, you probably don't need to see that about 100 times over. There's really nothing too interesting about that. Or maybe I'm trying to hide my atrocities from the Sparky boys. You be the judge. So testing was then done, and besides a little hiccup, the problem was relatively easy to spot and correct. I now hook up 3 new run capacitors and begin the practice of voltage balancing the 3 legs of the output. Unfortunately, I don't have any footage of that, but I'll offer a brief explanation later. Alright, I know I got some explaining to do. Here's the final result. Here's the diagram. Goodbye. Just fooling. Let's get into it. I'm going to do my best to explain this as simply as possible, so bear with me. So the e-stop controls the 220 volts to the step-down transformer. Indicator light indicates said power, and the start button takes the 24 volts out of the step-down transformer and controls the start contactor. Now let's get into the real meat and potatoes of the whole thing here, the start and the run contactor. Alright, so when the start button is pushed, 24 volts comes down, goes into the coil of the start contactor, and with the other side being attached to the other side of the step-down transformer, it's going to close. With the start button still being pushed, several things are going to happen now. We're going to do this in ultra slow-mo so you guys know what's going on. The auxiliary contact on the start contactor is going to feed power to the run contactor coil, closing it as well. The auxiliary contact on the run contactor is going to close. Power is going to be continually fed into the run contactor even when the button is not being pressed, so it's going to stay latched. But wait, there's more. I should also mention that L1 and L2 going into the run contactor are always live, and now they're live coming out as well. And L1 and L2 are going to this lower portion of the bus bar right here, L1 and L2, where it's distributed to the motor, the run capacitor bank, and the three-phase device. At this point, all we are missing is our special little guy, L3, our third phase. Here's how we get it. L1 coming out of the contactor splits and goes to the start contactor as well. So comes to the bus bar, and the bus bar loops it back around to the start contactor. With the button still being pushed, it's free to pass through here and go into the start capacitors, the spank of 3 right here. Now, the purpose of the start capacitors is to generate a large amount of power that's shifted 120 degrees relative to the second phase and send that to our motor. This is going to cause the motor to spin, but for the motor to only run on 2 phases, it's going to need to reach about 75% of its operating speed. Okay, so sped back up, that was only about 2 seconds of button push. The motor's up to speed, and we take our finger off the button. Start contactor opens. Power is no longer being sent to the run contactor or the start capacitors through the start contactor, but who needs it anyway? Not this circuit. So now we have 3 phases being generated, L2, L1, L3, but our third phase is all out of whack, with the voltage far different than line 1 and line 2. Allow me to introduce you to our run capacitors. These oil-filled caps are tasked with the job of smoothing out the voltage differences between each line and correcting the power factor. I'm not going to go into much detail since I'll likely misspeak more than I have in the past 12 minutes or so. Alright, now that you got maybe a basic understanding of the circuitry side of things, well, I hope you do, I'll show you the rest of it. I put it inside a nice little box with some latches on the side so I can get in there. Just some strain relief so it's not pulling on these cords. It's all inside of there. You can see on the bottom there that red, that's just a polyurethane bumper that I got. I had some extras laying around for car suspension, but it does a pretty good job holding it on there and keeping the vibrations down. They're compressed quite a bit. I had to take the fan cover off to fit it in here, but it still pulls a decent, it actually pulls a lot of air through there. You can see I have outlet holes there, and I have some inlet holes that I sanded these edges with because right now The most noisy thing about it is the air noise. I think it's well put together. You tell me. Never done this before. I'll close it up. Latch these down. Plug it in. You can see it's not too noisy at all. If I cover these back vents with a piece of paper, you can see it gets even quieter. Yeah. Alright guys and girls, appreciate you sticking around for that. Hopefully some of it was useful. Stay tuned in the next video where I hook it up to the controller and see if we can get this FANUC to move. If you enjoyed the video, go ahead and hit the like button, subscribe if you dare, and thanks for watching.